Boy oh boy, have you ever tried to use the core data services that are part of the RESTful Application Programming Model of SAP to access data from external services instead of data that is stored in S/4HANA databases? Well, that's exactly a requirement that I had for one of my own products, and in this video I will share with you how to do it. If you're new on here, hey, I'm Robert, and if you're interested in topics like this, please consider giving a like and subscribe so you guys can keep up to date with all of our videos. As always, I will start with a live demo and show you the solution that I've developed, and then I will share with you how you can do this as well. Now without further ado, let's get to it! Alright, let's do the live demo of the application that I've developed. Basically, you can enter an address here in these filter fields, the country, state, city, postcode, and the street. And if you hit go, the application will return the indirect tax rates for this location. While we have very simple tax rates in Europe, where we basically have one tax rate per country, we have very complex tax rates in other countries like the United States. In the United States, the tax rates can differ between states, cities, zip codes, and even streets. Additionally, the tax rate isn't a simple tax rate. It consists of several tax rate items. So I will start with a simple example here. For example, I will enter here AT, which is the country code for Austria. And then I hit go right above my head here. As you can see, we have a value-added tax here in Austria with a tax rate of 20%. And here I display several other information concerning the criticality of the result. Please note that this information does not come from a SAP HANA database, but from an external service. In my case, this service is Global Tax as a Service, which is my REST API that runs in the Google Cloud. But now let's try to enter an address in the United States. I remove this country here and I enter US for United States. In the state field, I enter CA for California, and in the city field, I enter Mountain View, which basically is the city where Google is located. In this case, I also have to enter a zip code, which is 94043. And here in the address 1 field, I also have to enter the street, which is 1600 Amphitheater Parkway. And then I hit go. Again, the tax rates are retrieved from an external service. However, the tax rate of 9.125% is calculated from several tax rate items. You can see this by the information combined here, which is yes now. And if we click on this item in this list view, the object page for this item is generated. And here on this object page, you can see not just the address for which you did the query, but also the combined tax rate and additionally the tax rate items. So here you can see that we have a tax rate for this address that consists of a county tax, a state tax, and 2 special taxes. Additionally, you can click on each line item here again and see another object page. So on this object page, you basically would just see the state tax. So now let's move back to our original query. And that's basically all for the live demo. But now let's look into the source code on how we built this. For this purpose, I open Eclipse, which is our source code editor for abap. And here on the left-hand side in my package, under Core Data Services and Data Definitions, you can see that I have created 2 CDS entities. The ZI tax rate UQ, which stands for unmanaged query. that basically creates the item here on the first level here, and the ZE text rate item UQ, which basically is responsible for the information that gets retrieved when you click on this item and you see the information from the text rate items. So first let's look into the CI text rate UQ CDS entity. As you can see here, this is not a CDS view entity, but a CDS custom entity. So whenever you want to retrieve the information from an external service, you have to create a custom entity for it. You can create a custom entity by right-clicking on the Core Data Services folder here on the left-hand side. Then you choose New and Data Definition. In my case, the name was ZI text rate UQ. However, you can enter the name you need here. For example, ZDemo UQ. UQ stands for unmanaged query. However, as mentioned, you can name it as you like. Then you enter the description and you hit Next. Here you choose a transport request or you create a new one and then you hit Next. Here in the template section, you have to scroll down and here you find Custom Entity Creation. You open it and here you find Define Customer Entity with Parameters. You click on it and then you hit Finish. And this creates a new custom entity definition, but with parameters. However, in my use case, I don't use these parameters, so I can delete this line at all, since parameters require you to enter the information in these parameter fields. Instead, in my case, the parameters are optional here. So basically these are filter fields, not parameters. So you can enter information here, but you don't have to. So if we switch back to Eclipse and to my text rate unmanaged query here, to my custom entity, and here you also can see that I have added the root key here. This basically means that this is the root entity that can contain child entities as well, like in my case, that are the text rate items. Instead of parameters, I use the key fields here for my filter fields, which are these one here, these ones. Then you have to define the fields that you want to display here in this list view. In usual CDS view entities, these fields get filled from the S/4HANA database. However, with services and custom entities, these fields have to be filled from your ABAP code or with your ABAP code. For this purpose, you have to create a new ABAP class. In my case, this ABAP class here is in the source code library under classes, and it is named ZCL text rate UQ. And you have to add this implementation class as annotation here, as you can see here, to your custom entity. So basically, you have to enter add object model.query.implemented_by here, and then you define your implementation class here. Before we look into this implementation class, we also look into the text rate item unmanaged query here. This one is also a custom entity, and it contains the text rate item fields that we've seen here under text rate items. As you can see here, I've implemented the logic for the text rate item unmanaged query in the same ABAP class like or as for the ZE text rate custom entity here. In order to handle the association from one tax rate to many tax rate items, we usually use with classic CDS view entities, we use the association tag. However, with custom entities, we cannot use the association tag, which we would use here. Instead, we have to create a composition. Therefore, in our tax rate custom entity, we enter a composition for the tax rate item as follows. Composition one to many of tax rate item UQ, which was this one here. And in this tax rate item custom entity, we have to add an association to the parent custom entity, which was this one here, with a projection on all the key fields that we have here in this custom entity. But now let's look into the implementation class here, which is the implementation class for both of our custom entities. Let me delete this demo class here before we continue, since this gives me some errors here. So I'll delete this one here. Okay. So now we are back in our implementation class here. As already mentioned, this implementation class implements the logic for both custom entities here. This unmanaged query implementation class has to implement the interface if RAP query provider. Then we scroll down here and you can see that here in the select method of the interface RAP query provider, we can get the entity ID, and when this entity ID is this one here, we implement the logic for this custom entity, and when the entity ID is this one here, we implement the logic for this custom entity. Let's scroll back to the main entity here. If you use parameters, then you have to call this one here, IO request get parameters. However, as mentioned, in my case, I do not use the parameters. Instead, I use filters. Therefore, I have to use this command here, IO request get filters, and I retrieve the filter as SQL string. Then I've developed an internal method that extracts the fields, the filter fields here, these ones here, from the SQL filter that we retrieved here. Then I retrieve the tax rates from the remote API with this method. I will not cover in detail how to get these tax rates from the remote API, since I made a separate video about this. This video is called SAP Communication Arrangement and ABAP Client. So if you're interested how to get these tax rates, then you can watch this video. But for now, you just need to know that we get the tax rates here in the structure tax rates combined. Then I sanitize these fields for insert into a table. And here I create an internal table of ZE tax rate UQ. And that table now has the structure that we have defined here in the custom entity ZI tax rate unmanaged query. So we switch back to the implementation class here. And here you can see that we insert a row into the table, into the internal table LT tax rate with the fields that is defined in that are defined in the custom entity and that we retrieve from the remote API. Once we have filled this internal table, we can check if the data is requested, or we have to check if data is requested, and additionally we have to handle paging. I handle the paging in a private method here. However, since I return just one row here, I do not have a very complex paging logic here, But what you have to do here is you have to call at least this method here, IO request get paging, get offset, and this one here, IO request get paging, get page size for the page size. Important to know is that even if you don't need this paging, like in my case, you have to call these methods, because otherwise you would get an not implemented error. Now let's scroll back again. And now you have to call the setData method in the IO response object, and you pass in the local or the internal table LT text rate in my case that we've created before. Additionally, you have to handle the total number of records requested here, which comes with IO request is total number of rec requested. And here you have to set the total number of records that you returns, which basically is the amount of records, the number of records in your internal table. I can get this number with lines and the name of my internal table as parameter here. So that was basically the logic that we need to display this line here and to display the information on the object page that we have here under text rate. The annotations that we need for this layout I will show you a little bit later. But now let's look into the logic that I've created to get the text rate items here, but also into the logic that gets executed when we click on one item here. So we switch back to Eclipse, and here we find the text rate item here. This is still our implementation class here, and we are here in this case IO request get entity ID. First we covered this one, ZI text rate unmanaged query, and now we look into the ZI text rate item unmanaged query logic. Initially we do the same as above. We get the parameters and the SQL filters, and we get the text rates according to the filters. And then we create an internal table. This time we use this structure of the custom entity here, of this one here. Then we loop over the text rate items here. So this is basically these text rate items here. And we insert them into our internal table text rate item. So for this case here, we can simply return the internal table here as well. However, when a specific item is chosen here, then we do not retrieve just the filter fields here in this SQL filter, but we also retrieve an ID. So I extract this ID here from the SQL filter, and this ID is part of the custom entity here. And if this ID is not initial, which means that this ID was provided, then we additionally make an select request to our internal table, and this time the SQL filter here contains all the filter fields, which basically are these ones here, and the ID of a specific text rate item. So that was basically the whole logic for our two custom entities for these unmanaged queries. And now let's look into the metadata annotations that we need to display the information in this UI. First, we have to add this metadata.allow extension annotation to the custom entity, and we have to set it to true. This is required if we don't want to add the annotations directly into this custom entity, but into a separate file. We create this separate file with the UI annotations here in the metadata extensions. And here you can see that I've already created two metadata extensions, one per each custom entity. We look into the metadata extension for the text rate unmanaged query here. Here I have defined the annotation for the header. That basically is this one here. Then I created the UI facet for the 3 object pages here. These are the address page, the text rate page, and the text rate item page. As you can see here, when we click on this item, we see the object page, which contains the address page here, the text rate page here, and the text rate items page here. For the text rate items page here, we need to set the target element to underscore text rate item. That basically is the name that we defined here in the composition. Then we create the filter fields here with UI selection field. We do this for each selection field, and we also define the position here, and we hide it on the line item level, but we display it on the object page. Then we display these fields in the list view here. We do this here. If you scroll down, you can see here the label, text rate label, the rate, and so on. We also display these with the line item annotation. We display it also on the object page, and therefore we use the UI identification here as well. However, here we use the detail qualifier that we defined in the facet here above for the text rate annotation for the text rate object page. Eventually, we display the criticality of certain fields, like combined, for example, here. But in order to display this criticality here, as you can see here, these symbols here in color, I also had to add number fields here, like here in the custom entity. And depending on this number, a certain symbol and color is displayed with these fields. So if we look back into our implementation class, you can see here when we fill this internal table, I also set this field here, combined criticality, with a variable that I've created in this method. And here in this method, you can see that the criticality 3, for example, is the color green, or the criticality number 5 is blue, and the criticality 2 is orange, for example. So the last thing that now is missing for our app is the service definition and the service binding. As you can see here under business services, I've created a service definition, and based on this service definition, I've also created a service binding. In the service definition, I've exposed both custom entities as contracts for the OData 4 UI. However, there is no difference as you would do with regular CDS views as well. And then you also need to create the service binding for this service definition, and you need to publish it. In order to be able to publish this service, don't forget to save it first with F3, then you can publish it. And then you see these custom entities as entity sets here. Additionally, you see the composition here as well. Eventually, you can click the preview button here on the right, and then you will see the application as you built it. So that's all for today. If you like this content, please consider giving a like and subscribe so you guys can keep up to date with all of our videos. Thank you for watching, and see you in the next one.